a wild full stack React framework appears. And I want to be clear, this isn't a random framework by some random dude. This is Tanner Lindsley, who created React Query, React Charts, recently created TanStack Router and TanStack Forms, and so many other super important tools. There are a few people who are as important to the React ecosystem as Tanner. So him introducing a new framework to compete with the likes of Next and Remix is very exciting, especially since it's built around his router, which is one of the most exciting routers that I've ever seen. Check out all my coverage of TanStack Router in the past if you're curious. It's very early, but TanStack.com's TSR branch is already being built and deployed to Vercel using our new experimental full stack template, TanStack Start, which uses TanStack Router as well as a splash of Nikhil's Vinxi. Vinxi is a very interesting project. The TLDR of Vinxi is it glues all the pieces you need across Vite, Nitro, and all the bundling chaos in order to give you the necessary building blocks to build your own full stack framework. So if I was to build my own competitor for Next and I wanted to add server components, all the fancy Vite bundling features, all that type of stuff, Vinxi is a great way to do it. It's also really inspired by Bun, which is cool to see. Vinxi's a dope project. I screwed up not starring it. That has now been fixed. And Nikhil's an absolute legend. Used to be deep in the Solid community, still is pretty deep there. Helps a lot with Solid Start. But and having all these pieces here that are used to power Nuxt here for anyone to use is super cool. Previously, Vite and Nitro would have been things you assemble and set up yourself for something like Nuxt, which is what they're actually doing on the Nuxt team in the Vue world. Now you can do it yourself over here. And it seems like more than anyone, Tanner and crew are very excited to take advantage of that opportunity. That said, they don't have immediate plans for server components. And there's been an interesting back and forth I want to cover. And then I want to go actually dive in and play. Tanner said that for now, they're not planning on supporting RSCs because there's no docs on RSCs for framework authors, which is a very fair critique. If you're trying to build a framework around RSCs, there isn't really a path there on how to implement it, which is annoying because they're not very simple to just implement. And as you would expect, Dan shows up. For which bundler? I don't mean this as a troll. If you have bundler integrations going, the RSC for Frameworks API is kind of a single function call. Would documenting this one function be enough? It would help to know which areas are most needed, as well as a link here to the render to pipeable stream. I know way too much about this function. In fact, I actually wrote an implementation in the original TanStack router using pipeable stream in order to try and get a really early server-side rendering prototype. Troll, if it's a single function call, could you make a quick PR? In all seriousness, this feels hand-wavy. Next didn't spend thousands of hours and dollars to add a single function call to their new router. They didn't hire core React team members because it was easy to accomplish. This part I don't love as much. We'll go into that later. If it were truly this simple, Remix would already have launched their support. I'm honestly looking for practical guidance here, people who understand the big picture enough and care enough about RSC's future to be willing to get their hands dirty with me. The ideal person to write these docs and consult the ecosystem would be someone who has built their own SSR router, like React Router, but without RSC support. And then they would document what it takes to support it. This is where I and many others are today. Empathy makes great docs. I like this wrap up for sure. I'll say there's a lot of reasons core React team members were hired at Vercel. Specifically, core React team members that were hired were really focused on server-side stuff. And server-side JavaScript is not a thing that Meta invests heavily in. It's a thing that Vercel does invest heavily in. It makes a ton of sense that these people would go to Vercel, not because it's necessary in order to make RSCs work, but because they wanted to work on the server and this is the place that they want to be. So that's my only issue with what was said here. Everything else, fully agree. Tanner being based as always. I mean, I probably should put up a PR. It's just not my job anywhere more, so maybe in spare time. My point was most of the work is this. One, building a bundler integration, presumably lower level than what you're asking. It's not documenting RSC. And point two, which is figuring out your routing and caching strategy. This is a ton of work, but it's up to the framework and also not about documenting RSC. This is another important part. RSCs, the core raw concept, are actually very simple. And there's a couple other frameworks that are already doing this. I know Daishi's been working really hard on Waku, which is a super minimal React framework that gives you server components. It was meant to be initially a demo of what a server component framework would look like, and it's not too complex. I've read through a bit of the code in the past. Also, all TypeScript, which is really nice, not a single JS file in sight. But I've been really impressed overall with Waku. It's surprisingly simple and readable. Here's the server file. Define entries, render entries, get build config, SSR config. All the entries are handled. We set the render context for when we're rendering. Obviously not for public use, but this is for actually applying context in different conditions. And grab from the context, which he's a big fan of using context in all sorts of ways. It's Daishi. He's the state wizard. Here's their default template. The big piece is there's multiple entry points because you have to handle all the different routes that might be rendered, including a render strategy. So here we're making all of these pages static paths. So these will all get built on build. We have a root layout, which is rendered at the root path. We have a home page, which is also rendered at the same root. And we have a static about page, which is rendered at /about. Here's all of those templates. If we go to them, we can see these are just server components. And here we have a fake async get data function that we use for the about page to generate the page. If we go to a more complex example, like with their actions implementation, you'll see it's still not too bad. Here, this file is marked as use client. We have a bunch of stuff going on in here. We import some stuff from React. There's some not great typecasting here, but it seems like the TypeScript's honestly one of the harder parts here. If we go and look at the increment function in funcs, we'll see this is marked as use server. So Waku already has a pretty solid working implementation of all of these things. Obviously, this was not super trivial to make. And a lot of why this could happen was Daishi joined a Facebook group for chatting with the core React team in order to figure these things out. The result's dope. So you can do it. The tools you need are out here. That said, documentation on how to do this isn't like a page you go to that clearly describes it, and the different behaviors you might want in these different frameworks are entirely different. And it's hard to draw a line of here's the core primitive. How much do we guide you to the correct implementation versus how much do we just tell you what the primitive is and let you figure it out from there? Because we don't want every server component framework to be exactly the same. And that's a hard line to walk. All of that said, we're not here to talk about Waku and Daishi, as incredibly talented as they are. I want to focus on TanStack Router, the TanStack Start new template/framework, as well as the introduction of RSCs possibly to it. Again, with the 2 points Dan said here, a lot of effort was spent by the Next team on one, which was building deep bundler integrations to get RSCs behaving in all the different ways they wanted to. It was very expensive to do that, and that's a lot of where their effort has gone, but that's because of the ways Next wanted to use it. For 2, we've made suggestions like that start transition is crucial for routing. I recall you dismissing that and instead prioritizing fine-grained re-rendering, which I can also understand, but I'm a bit surprised to hear that you're interested in our recommendations. Again, how much should the React team be recommending versus showing? Chaos. Hard to make these decisions. That's all to say it would help to understand which specific points are most helpful to document. Remix is doing both 1 and 2, and yes, doing those is hard work, but I'm still not sure that these things are what you're missing. What documentation do you expect and for what parts of the API? Also worth noting that 1 is something I would expect Vinxi, which you build on top of, to take care of, and 2 is something I'd expect you to have your own opinions about, so I genuinely don't know which direction the gaps are in. Nikhil jumped in, always good to see him. Vinxi does take care of 1, but 2 also depends on people's understanding of 1 well enough, and then also know enough about the paradigm's intricacies. Maybe some more white papers or code walkthroughs of Next.js implementation. People need to know enough to have opinions. I like that there. People need to know enough to have opinions. I feel like this is what's missing. People are so much uncertain about server components themselves and how they work, so much so that they aren't as confident about their own takes on it. And in order for us to have good opinions about how to use server components to build these new frameworks, we need to deeply understand them first. And that's not as simple as writing some docs. But not saying this is all the React team's job. People need to do their homework too. Read the source code. I think Luby can vouch for how it would be impossible to get the whole picture without reading the source code. Luby is another deep server components individual. She's great. And great person to cite here. As always, value Nikhil's input. Enough about the drama on Twitter though. I want to actually play with this. And thankfully, I got the project downloaded locally. Thank you, Tanner, as always. Resolved relative to absolute. Good old path handling. Everyone's favorite. Custom Beat server. This is wrapping Beat with all the chaos that they need to engage with. We resolve all of these packages. But here's where things get fun. Export default, create app. We have a preset for serving it on Vercel. Vercel's a surprisingly nice place to target for a lot of these types of services because, the Vercel build output API is very well documented for running things both like the cache on a CDN as well as on servers, lambdas, edges, whatever you want to run it on. It's a really nice thing to target when you're building a framework. And I can see why that's a top priority, both because they're already deploying on it and it's one of the easier targets when you're doing all this fun, chaotic serverless stuff. Now we have the routers. We have the public router, which is served from the public directory, which means this is going to come first. Anything you put in here will be the top priority. If you go to a route and it's not served by something in public, then we fall back and go to the SSR route instead. We check the app server TSX. We make sure it's clear to the bundler. This is targeted on the server, so it should run there. We have all of our plugins that we're using on this render path. And we also link it to the client so that the client code can be loaded in as well. Then we also have the client path, which is handled by app client TSX. This targets the browser, so this will be compiled differently. It has a base, and it has all of the plugins that are needed on the client side as well, including, you'll see, React refreshes in both. Interesting. Also, server functions.router. This is for things like your server functions, your equivalent of actions. Very excited to see what these are used for. Now that we know all of that, I want to check out the app client TSX. Cool. Render, start client. This takes in the router. If you're not familiar with what's going on here, an important thing you need to know in React is that in order for your page to be functional once it's been rendered on the server, a thing called hydration has to happen, where you're effectively rerunning the same JavaScript on the client that you ran on the server in order to link up all of the React components to the actual elements on the page. With server components, this behaves a bit differently because there are some components that only run on the server. But with this model and what Tanner's working on, all components run on both. So you need a way to pass the data to the client, which they're all going to handle for you. you on the route level. But in order for this to all come together, you need to run some slightly different code on the client and on the server, where the server code will fetch the data and then the client code will use the data, but they both render out the same HTML as a result. And that's what this code here does, is it takes the router definitions that we have defined already. It uses those to start up things on the client side. And then it, from all of that, renders hopefully the right page with the right content and syncs it all together. We also have the hot reload handled here too. And if you want to see the server side, it'll be a little more complex, but very similar overall. The difference being we're not trying to hydrate the HTML, we're trying to generate it in the first place. So we take the event, we turn into a web request, we get the URL out of it, we replace the origin, so we have just the URL path. You'd be amazed at how annoying it is to just get a clean URL path from things. This is probably the right way to do it. We have client manifest, which is actually getting the info for the client for all the assets and whatnot. We collect all the assets, we filter out anything that's Nuxt DevTools, and then we push the script tags for all of the script stuff. We create the router, we create a memory history for the router, we update it with the new history and context with all the assets that we just found. We run the load function, and then we create the stream. Remember that thing I said earlier about render to pipeable stream? This is the key function for server-side React code. This takes the React code, it runs it, and it pipes out a stream of HTML that you can use for other things. So this stream gets piped, and eventually, when it's done, it resolves it so that it can start piping the HTML all the way to the page. Then we have the transforms, transform stream with router, add router transforms to the stream. Interesting. Not sure what these are being used for, but the idea of getting the content from React and doing things to it before it gets to the client is exciting, and I am sure that there will be plenty of chaotic things people will do with this. Can I see what this is being used for here? I cannot. Exciting stuff. Transformed stream is the result of that. We grab any headers that we want to assign, and then we return the response. Good stuff. Then we have a get hydration overlay script context. Oh, I've had to do this too many times, where you put a JavaScript script in a string so that you can call this and render it embedded inside of the script tag in the HTML output, because React doesn't give a shit on the client side about what's in your head and your script tag if that's not where the React app is mounted. So this lets us handle all of those things here, embed them, and then the client doesn't worry about any of this going forward. Really nice stuff. I want to see what this actually looks like to use though. So if we go to, let's take a look at the blog. Interesting. This is just markdown files, which means that what they're building here also handles markdown. Localhost 3000 blog. Hydration mismatch occurred. Everyone's favorite. On the bright side, the hydration errors are already better than Next's. That's nice. We can take a look at blog TSX. Ooh, good. Type errors. It's not assignable. Cool. So that's a route that it doesn't want to be able to go to, I think. Interesting. Export const route is create file route. Again, really, really cool. This is all just generated route code. Once you've defined this, it gets handled for you. We have a post not found. And of course, the outlet, the most important component in any of these more nested frameworks. Really, really cool stuff. So the code base doesn't run on my machine locally. Lots of potential reasons as to why. But what we can see here is the real site. We can also see the network profile when I do that. So let's open this in an incog so that we can see how this behaves on the network. Let's clear what we've loaded so far and load the TanStack Router page. Look at that, just hovering over things. We're already doing background fetching and a little bit of waterfalling. Resizing fetched all of those images again to be the right size. That's exciting stuff, that all of that's already baked in. A lot of that's going to come from like the Vite and Vinxi ecosystem, but having image refetching based on the size of the images, that's good stuff. Let's take a look at how an actual route change goes though. Clicking now. Still loading a bunch of things, but it's doing that relatively parallel. You can see clearly when I started loading the new page that the web container load, the fetch worker, all of those things started. Did something else start before then? Yeah, here's the real gap. So we called the underscore server call, TSO TanStack underscore server function ID name. This is just saying, hey, TanStack server, I need more info. Give me what I need for this page. And this responds with a ton of additional data that might be needed for this page. It seems like this one is just the call for all of the supporters, which is like the little git dump here for all of these people and their profile pictures is where most of that data is coming from. You send me the environment variable file. Oh boy. pnpm dev, and hopefully now, oh shit, that works. That's really cool. Like obviously it's running on my machine, but the fact that these routes load instantly, these pages all exist and work in such a new thing. That's really cool stuff. So we can go to this TanStack Router routes. And the URL is just router latest. Interesting that it's handling versions for us. I know why Tanner needs that, because maintaining docs for lots of different versions is not fun. And he's just kind of handled that for us with all of these version.tsx files. So if available version.concat latest includes this version, we throw. Otherwise, we handle it. Usually when I'm looking for something like this, I'll just do this where I copy some text and then I can usually find, cool, there we are. So here is the file I was looking for, which is libraries, router, version, index. Very similar to how Next does the underscores to hide something that's there for us to manage our files, but is not part of the routing. It's an interesting pattern. It's cool to see these things being adopted. I'm still not the biggest file-based routing fan, but it's cool to see it handled this well here. And obviously the ability to go back to a more traditional config-based routing, which is what this is all based on. They're not hiding all of that from you, which is, again, very different from other solutions. The whole routing tree is just here. You don't have to generate it. You can make it yourself if you want. But here we have a use effect for setting dark mode. We have a gradient text, which is Tailwind to do the gradient text stuff. And also we pass color from and color to, so we can reuse this for different places. What I want to highlight is how different this behaves from other solutions. Honestly, the incog might be the right place to do that still. So if you were using the new server component stuff with React and Next, and you go from one page to another, you're going to see interesting things load. It's going to load some partial HTML through a JSON blob. It's going to load some new JS if it's necessary, and then it's going to load any other assets and things on that page. Here, it's going to load different things because, again, a lot of that stuff is handled, so to speak. That might not be the best example because it's loading the giant web embed. They both use the stack blitz embed, which is going to clog up the network tab pretty bad. I could just hide that part in here. I will comment this out and we'll test it in form then. I want to demo the actual behavior in the network tab here, which is one of the most important things when building a new server-side framework router, any of these things. So if I load a new route like TanStack form, it comes up almost immediately. If we look at what is here, this is just some data that the server sent, which is very different from how something like Next would work, where it would send you the new page content, especially with server components. Because what's happening here is once that first page has loaded, everything from that point forward is client-side routed. So if new data is needed, that data will be fetched via this server call such that the code can be run on the client. This is different from server components, which would be sending you some HTML that you would render instead, and then the JavaScript takes over underneath, where your JavaScript's just for the interactive leafs. This is for the whole page being interactive. I will say for docs, this might not be the strongest technology, but for something like an admin dashboard where you want the first load to be good and accurate, and you want everything else going forward to be performant and local, this pattern makes a ton of sense. This is, in its current state, one of the most minimal server rendering React solutions I've seen, where it's still very SPA-y. It's still meant to lean heavily in the single page app direction. And we see that with all the things that get loaded here. I change this to be showing me the JS that loads. Go to a different page. We'll get no new JS. I go back. I'm going to Command-Shift-R. It loads all of that JS initially. And when I go to other pages, it might load some in the background, but it probably won't need too much. And if I go back to the form page, no new JS loads, no new data beyond this one server fetch for this additional stuff is loaded. It makes all of your navigation around the site going forward feel significantly better. There's two axes here, honestly. One is build versus load, and there is navigation. Traditional SPAs handle loads in a way that is relatively simple to understand, but has a lot of complexities once implemented. So with an SPA, you have a couple steps. First is build a minimal HTML file. 2 is load a ton of JS. 3 is JS fetches things from the server. And now all future navigations, all things you do are going to be done via the JavaScript on the page. You'll never ask the server for new HTML again. You get the minimal bit of HTML right at the start, and then everything else going forward is the JavaScript fetching via an API call to whatever server. So here's the Twitch homepage. You'll see there's a ton of content in this HTML. If I just right-click inspect, this gets super nested. There's a ton of stuff. So if you check in the network tab, you'd probably expect a big page to be loaded. But if I go up here and actually look at the page that gets loaded, I'm going to open this in VS Code so we can read it a bit better. Here is all of the HTML content for the Twitch homepage. We have a bunch of built-in CSS for the shell. And then we have shell nav. And that's it. This is all of the actual HTML for the Twitch homepage. So how the hell is it so interactive? Where's everything coming from? It's all getting loaded via the script tag. Well, the set of script tags up here. So we have a JSON tag for basic info that we embed to use for different things. We have another script tag that loads dark mode as soon as the page loads. We have another script tag that is used for performance. And then we finally load the actual JSON and JavaScript for the page itself. And then this is what loads, fetches all of the things that are needed, binds to the GraphQL endpoint for Twitch, and then fetches all the data and loads your React code. But all of that comes from these JavaScript tags here that do the actual work. The HTML the server gives you has basically nothing in it. In order for the page to get painted with the correct data, it has to fetch from the server. But it's fetching via a GraphQL endpoint the data it needs to render the right content on the client. The content itself, the thing being rendered, is not determined by the server. The client determines it. The way that server components work is a little opposite. If I go to the upload things site and open up the network tab, and I have to do a navigation, let's go to the pricing page. You'll see here that I'm loading something that doesn't look like code a human would ever write. We have static chunks, we have div, null, class, flex, hscreen, all of this content here. And all of this stuff here is the actual HTML contents. It's flattened in a way that React can deal with it, but this is HTML in a weird format that Next and React use to actually paint the content of the page. So when we load this page, when we just Command-Shift-R it, if I go to the network tab and we look at the actual HTML here, this is the whole HTML for this page. I could copy paste this into another file, load it as just a .html file, and it'll be formatted correctly as long as the CSS is there. And the reason for that is the server's actually running the React code in order to get this content. Future navigations will work by fetching that set of data in the JSON that isn't really HTML, but it is effectively HTML. It's HTML serialized in a format React can understand as we navigate around the site. And all future navigations will be done via waiting for the server to send that updated content to you. But that is code the client runs once it's gotten the new HTML, and it just says, here's what the HTML should look like here instead. And then it does it. This is an important detail because server components only run on the server. So if the client was to try and run those, it would fail because you can't await a DB call or do a lot of these other things that you might be doing in server components on the client. You might not even want to load all of that JavaScript. There is something in between these, and it was the default for a bit. We'll call this the SSR way. So on initial load, we render HTML on the server. JS loads after to hydrate whole page with embedded data from server. This is an important piece, the embedded data from the server. If I was to go to ping.gg/call/demo, which is the link we use for demos for our calls, you'll see in here, there's actually some junk in the script tags. Specifically, we have this next data that has this giant dump of things. This is all the data that the client needs to render all of the states the page could be in, and that was returned via the getServerSideProps function. When you use getServerSideProps on a page, in order for that page to render on the client, they actually have to dump all of the data the page used on the server such that the client can re-render. And that's the same way TanStack Router is working. If we were to go check in here and look at the elements, we have TanStack Router dehydrated. Here is similar data that's used for doing the hydration and dehydration and allowing the client to get what it needs to stay up to date. That is the core of this pattern that's important to know. The data has to come from the server embedded in this initial HTML. And it uses the embedded data when the same React code reruns on the client in order to make sure the page comes out the same on both sides so React can run properly going forward. And then future navigation loads JSON data payloads to pass as props to React code. And this is the key difference. In the SPA way, you load empty HTML that loads a bunch of JS that fetches its own data, and then JS fetches things from the server going forward for re-rendering. The SSR way is the initial load has the correct HTML because you load that on the server. Future navigations still fetch from the server the same way this did in this example, and then future navigations will load that JSON data instead. And the server component way, which is all loads that do any type of navigation are running React code on the server to generate the new HTML content that the page needs. The JS loads after it's been sent that in order to hydrate and make React interactive, as well as get these new HTML payloads when they're needed for refreshes and reloads and navigations. And again, those future navigations are fetching the HTML from the server instead of a JSON blob that is used to render the same code on the client. This is kind of an argument of when is React run on the server? React never on server is for SPAs, like this large in red because it's important. SSR, React runs on server once. And then RSC is React runs on server for all navigation. Those are the core difference between the three. It's also worth noting that the SSR way, this is how old React and Next worked with Pages Router. It's how Remix works right now. And in this case, it's also how TanStack Router works. Generally, SSR, the traditional way, has not been the biggest focus of the React team, but that also leaves a huge gap for iteration. Because if your page doesn't need to really render on the server, all of your JavaScript content's fine to just ship to the user, and you want to get the data to the user as quickly as possible so the page can update and control everything on the client side. Again, imagine something like a dashboard where you're typing in search and have a ton of data coming through, having to wait for all of the content to be serialized on the server as HTML and sent to you. sucks. If you're loading a new page, that's fine. If you're typing in a search field and want every character to update the content underneath it, it's a little bit less so. Generally, you'd want to run a lot more on client if you're updating a lot more, and you'd want to run things more on server if you're updating a lot less. So for the upload thing dashboard, server components made a ton of sense until we got to implementing the file searching for actually looking into files and such. Then we went back into classic TanStack query plus TanStack table and all the things we needed to make that a good experience. This area is Tanner's area of expertise, highly interactive, complex data architectures. And he has now taken all of the benefits we would expect doing this the single page app way and gotten most of those working well in the SSR way. In fact, if I understood his chat message earlier, he even has use server working. This is really cool because it lets you define some code that runs on the server that does something like reading from the docs path here to actually get the path for the blog posts that he wrote. So app blog, here are the posts for it. We can load those using fetch repo file, which is fetching from GitHub, that file path. If it doesn't find it, we throw not found. Otherwise, we extract the front matter, we remove the markdown, and we actually embed this in the return. This content from fetch blog post is now a server function that can be called in your components, in this case, the route for the file route for the blog, where we load the data by calling fetch blog post in the loader. And once you put this in the loader, this now gets embedded in the route itself via one of those JavaScript like script tags that has all of that data embedded within it. This is the key. By putting that fetch blog post code in the loader here, whatever this returns is now embedded in the HTML of the page. And if you change routes, then it gets sent down as a new payload that the TanStack Router code will embed in the page the same way. So it's there for anything that needs it for rendering. And now you have this data loaded anywhere else that you need it. This goes even further once you add things like defer. Defer is a primitive coming from the TanStack Router. And when you defer something like the sponsor's promise, you're able to respond with this first bit initially and then have the rest come in later. So if I go back and I reload the homepage, you will see from the network tab that we immediately get a response that includes all the things we need for the core render, but it's still loading some stuff. What was happening there, if we look at the long request, is that the rest was coming through later. It was all being streamed in over time. The content download here being 4.81 seconds is because get sponsors for sponsor pack was intentionally slow. Yeah, so this call was slow. It takes some time to load. And as a result, this didn't come through immediately, but we're able to still serve the route with some of the data as we wait. I also want to do that and cancel. I wanted to show that the HTML content is incomplete initially and it gets fixed later. Non-trivial to quickly demo. Oh, that's also where the server transform comes in. Oh, that makes sense. Disable cache. I don't want to disable cache. I want to entirely stop this from loading once the first load has happened. I'm going to switch this to offline once that first load has come through. Theoretically, the page content now should only include the random number. Loader data, yeah, random number. And then we see the sponsor's promise is still in the deferred state. So the random number comes through immediately when the page loads because we're not deferring that. But the sponsor promise doesn't come through immediately because that's deferred until it's done. So the page can respond immediately and then resolve any promises later on as needed. Really cool stuff. The only reason this isn't resolving now is I actually turned off networking on my tab. But if I switch this over to fast 3G, I'm gonna need to refresh because I'm sure that killed things. Then you'll see this gets updated once the page loads, where it's no longer just the random number. Now we have all of this data, all of these UIDs and things that are coming from the sponsor's promise that was deferred here. So again, in Remix, a similar pattern where you can just defer part of a promise that you're returning from a loader. Super cool. And this is important because on a given page, you might have some components that can load later, but some you want to have load as soon as the page is there. So at a loader level for the route, you can determine which should or shouldn't block. To compare this to the new React model, though, one of the really cool things is instead of at the route level saying this data blocks, this data doesn't, you can at a component level say this component needs this data, this component doesn't because it's not asking for it, doesn't await it. And then you wrap them in suspense instead. That said, this is one of the nicest patterns I've seen for doing this way. And when you want to think in terms of here are the routes, here's how they work, instead of here are the components, here are the routes that come out, this is looking to be one of the best ways to do it. Although again, still very early. That does not mean I am not hyped on this though, because this is really cool stuff. Quick call out from Tanner. It's not done yet, but theoretically it's possible to do static site generation. So if we go back to my diagram here, instead of the HTML being done on load, it would be done on build. So you could have a bunch of different routes that have different HTML, where normally with a single page app, you have one HTML file for every single page. This would allow you to do way more while still not needing to run a server. Very promising stuff. There isn't a good way right now to generate 10 different HTML pages for your React app. You generate one, and then the React code runs on the client, or you go all in on SSR. And in between that doesn't require a server to run on each request is really exciting stuff. And I'm hyped to see what that looks like. Again, we were to draw like like lines here between these, where these are different amounts of like server involvement in how your content renders. I would say Next right now looks like this, where it's very much leaning into S or RSCs, but you can do some stuff with SSR. They support Next static, which would fit in between here at static export. But I'll be honest, static export isn't super well supported at the moment, and my faith in it goes down day by day. Where what Tanner's doing here right now, it's very much like this. But in the future, if he gets the static site generation stuff working, it could push more and more into this direction, which is very exciting. And if people push hard enough and server components get to a state that are interesting to Tanner, it could also push slightly into this direction too. But right now, it's fitting squarely in the SSR way to do things. Next and Next static export, do these. I cannot recommend static export right now. If you really want that, just use Vite. This is a very compelling new entry into this world. Also, for those wondering, Remix also very much fits here. I know they're working on some more SPA stuff. I haven't played with it enough yet to say for sure, but it seems like these two are explicitly trying to position themselves more into the SPA world as a happy path to have good HTML for every route, where Next and server components as a whole are rethinking where does our code run and render in the first place. Didn't expect this to become a breakdown of RSC versus SSR versus SPAs, but I feel like half the time I talk about React, this is what it ends up being. It doesn't mean I'm not hyped on what Tanner's building. He has historically been one of the most useful and important figureheads in this community for building stuff just like what he showed here. I am really hyped for TanStack Start, and I will certainly be playing with it more in the future. Let me know in the comments what you were most excited about. That's all I have to say about this one. Till next time, peace nerds.